Good morning.
Good morning.
Am I getting any sound? Getting a little bit of sound? All right, great. Thanks for coming out today, everybody. Good to see you. My name is Scott Persinger. I am with Heroku in the engineering group. I want to talk to you about this kind of new pattern for building applications. This is something that we've been using internally on some of our teams. But I think it's got a lot of good broader appeal. Before I get started, I'd love to get kind of a show of hands. Maybe who out there is like a hardcore Ruby on Rails type developer? Oh, just a few. Okay. Who is more back-end in Node? Who's using Node these days? All right. And what about front-end developers? Anybody using React or Angular type things? All right, good. All right, so we got a good mix of different skill sets and interests today. I want to give a quick shout out to a couple guys from my team, Howard Burrows and Jeremy West, who helped me put this application and this presentation together today. And what we're going to talk about today is this thing that we've been calling the 3R stack, real-time RESTful apps using React. And we've got a couple examples of these running within Heroku today. What I'm going to do today is actually present a demonstration app, this quiz game, along this pattern. It'll be a little easier to understand from a kind of limited example. So I want to just take a few minutes talking about sort of how we get here. How do we get to this stack today? When people first started building sort of web apps, we had this what I call the traditional model, really built around the HTTP protocol, the basic request and response cycle. Browser sends a request back to the server generates some HTML and sends it forward to the client. Remember this? Who did some good PHP programming? Come on, back in the day. Anybody? Getting the old school folks here. Yeah. So, the great thing was this was a very, very simple model. Super easy to get started. It doesn't scale very well to more complex applications, and that's going to kind of lead into the stuff we're talking about today. But there was a lot fewer moving parts and stuff to learn back here. So eventually some smart folks at Microsoft came up with this notion of AJAX. And they put this ability into the browser to make a server-side call for extra data that didn't reload the page. And that combined with the addition of dynamic HTML, the ability to mutate the page in place within the browser, meant that now you could build much more interactive applications because every time the user made an action, you didn't have to go all the way back to the server and re-render a whole page and send it out to the front. And this got us pretty far. Like, people built a lot of pretty cool interactive applications with this kind of pattern. The problem here was that you ended up having to commingle a lot of your application logic between the front end and the back end. Usually you would have like some sort of ad hoc kind of protocol or API between the front end and the back end to make a request. You get some kind of ad hoc packet back, and then you'd have a bunch of JavaScript to apply those updates on the front end. And so if you had a list of messages, there was like logic in the back end to generate that list initially, and then logic in the front end to manage it. So it became kind of hard that you didn't have a very good separation of concerns with this approach. So eventually, people figured out that, hey, why don't we just build the whole thing in the front end? Let's build single page web apps. We'll just bake everything based on this AJAX call. We'll just move JSON back and forth from the server. And what's really nice about this pattern is the separation of concerns. Now I can just build a server backend with a clean, RESTful, resource-oriented API. and I can build basically all of my front-end presentation logic within JavaScript as a proper application. And so people were doing this with kind of early version frameworks like Backbone, and now we have these kind of second and third generation frameworks like Angular and React and Flux. So why real time? What's missing from this existing picture with single page apps? Well, it turns out that actually I want to digress a little bit. People have been doing this pattern, trying to push updates in real time out to the browser for a long, long time. It's been at least almost 20 years for sure, through all sorts of different techniques. I can remember in like 97 seeing the demo of, the classic demo was the stock trading screen. I'm getting real-time stock market prices to my browser. That stuff didn't work very well back then, and it's taken us sort of a long time to get here, but now with standardization of WebSockets, there's a reasonable kind of push channel to push updates out to the browser. And it actually turns out there's a lot of different good use cases for this real-time pattern. One of the big ones that we're seeing a lot is any sort of collaboration type application. Anything with multiple users who are kind of operating on the same data set, it becomes very useful to be able to reflect changes made by any user to all the other users in real time. And one of the things you get from that is you avoid this kind of stale update problem where user A loads record 1 and user B loads record 1, user B edits it, and now user A is looking at the wrong version of that thing. Another great use case is any kind of real-time monitoring. I want to monitor some remote system. I want to just ambient collect state changes on that. I don't want to have to click refresh. A lot of a lot of what we've done in the past is polling. We set some timer, we poll new data, new changes every few seconds. And the problem is polling puts a heavy load on your back end, and in particular, it puts a heavy load not doing anything. You're not actually accomplishing any useful work. So what I'm going to talk about today is, probably a lot of you are familiar with this basic idea. We're going to open a WebSocket, we're going to push data out to the front, and we're going to show state changes in real time. And what I want to talk about in particular is how we took this pattern and used it with React and with the Flux architecture to come up with a really nice kind of pattern for how we can build our app based on a real-time view of our back-end resources in a way where we're not having to pull for changes to those resources, and we're not building sort of ad hoc API calls in order to request state change updates. So this gives rise to kind of this rich client architecture. This is primarily this falls out of just building your application based on a RESTful API. A lot of nice stuff comes out of this. Now, we compare this to sort of like the old, either the MVC server-side generated model or even like, the old PHP model. It's in some sense more complicated. I'm building this whole server-side API. Then I've got a bunch of, a whole application I'm building on the front end. But those separation of concerns have some really nice properties, like the fact that, okay, now I can build native mobile apps using that same API. And more, what people are seeing is I can also expose this API on the public internet and enable partner companies, partner applications to use my services and build this kind of network of orchestrated services. So services like GitHub, we have a whole public API at Heroku, like this is becoming a very popular pattern. And so the idea, I'll just use our internal case as an example. The Heroku Platform API is the API upon which our actual UI dashboard is built. And so there's really no like internal development that's going on. There's just this public API. Anybody could come along and build another dashboard that did something else. So the architecture I want to focus on today takes that basic pattern. On the server side, I'm going to use Node Express within Node. I've got Mongo for persistence. And then on the front end, the React library, the Redux library for implementing the Flux kind of architecture pattern. And then I'm using Socket.io to drive my WebSocket layer. And what I'm going to dive into is kind of how we hook up lifecycle events for resources on the back end to pushing those updates out over the WebSocket to the front end and then displaying those within React. All right, so let's dig into a little bit on the server side. Just sort of a side note, when I started building this kind of sample application, I started out with my REST API. I defined entities and the endpoints that I figured I was going to need for this application. I used this tool called Swagger, which has a bunch of open source tools, including this nice little editor where you basically go in, you write this YAML file on the left side, and on the right side it gives you this nice auto-generated documentation, and it'll even like generate client stubs for you. You can test endpoints directly within this UI. So there's I don't know if you can sort of see it at the very bottom on the right side, there's a try this operation button. You can like click that thing and it'll actually give you a little form. You can test out your endpoint right there. So I encourage people to check out Swagger. It's pretty cool. And this notion of kind of starting out with this idea that I want to have a well-documented API, both for internal usage, but potentially to publicize, more broadly. And I need a machine-readable description of that API that I can build tooling around. This is becoming much more of a common pattern now. All right, so the Node side is actually pretty straightforward. I'm using Express. I've got the Express router. In this case, I'm showing the endpoints for requesting the list of users, which are like the players in my game, and then the post function for creating a new user. So when you go in and register in the game, we're going to send back a post to the user's endpoint. I'll create a new user model, which is just a Mongoose model on top of on top of Mongo. And I'll go ahead and save that to the store and then return that new record to the user. So all pretty straightforward stuff happening on the server side. Just so you know that I didn't cheat, I did build Mocha unit tests for the whole backend API. This project's all on GitHub. I'll send out the link after. People can go check out the code. So I'm using Mocha and Supertest, which allows me to easily call and test my API endpoint. So this is just testing that, in fact, I can create a user with this post endpoint here in Express. All right, so let's talk about the front-end architecture here, which gets a little bit more interesting. So for people that aren't familiar with the React library from Facebook and the Flux architecture that sort of comes with it, this stuff can be a little bit mind-bending. It's a very different approach, a different model for building front-end applications in JavaScript. It's very different even from Angular, so even if you've invested time understanding Angular, it can be hard to kind of it was hard for me to wrap my head around how this stuff all worked together. The key, I'm going to dig into sort of all these parts in sequence, but the key sort of insight with Flux in particular, which is the application architecture, is this idea of managing state in a very clean way within your application and having state changes flow in a single direction. You can see that here in this diagram, this kind of circle between these components. State always flows in this very regular way. All right, the Flux architecture, sorry, so this is a little bit what I was just talking about, this management of state and the ordering within the application. The other part of this is this notion of actions, which basically, For some of the old timers in the room, we used to have this thing called the command pattern, which was the idea that you, instead of sort of changing your word processor document in place, instead, whenever somebody typed, you would package up a little object, encapsulate the new text, and say, this is an insert at this particular position, it contains this text, and you just create these commands that say, here's how I get from state 1 to state 2 of my application. And so Flux basically builds on this same idea. They call it actions. It's just a packet of state change that allows you to manage and reason about how your application is changing. All right, so digging into a little bit on the React and Flux now. I've got React is based on this notion of components, and in fact a component tree. And so, everything old is new again. Well, where sort of traditional web application design was all about building an HTML page, figuring out how to render it, and then we started adding dynamic behavior, figured out how to write JavaScript to mutate this thing. Well, predating all that, we had UI toolkits, which were all component-based. And so you just said, when I want a window, I'll just create a new window object, and I'll say show here on the screen. Well, React is sort of like, comes to that same, sort of recycles that old idea of let's combine presentation, let's have application code which represents presentation rather than having this separate markup, which we then have to have like a separate file of application code which kind of manipulates or generates on the server and manipulates on the front end. React says, forget all that, let's have this JSX, which is kind of a mixture of markup and code, and now we can just build a component which represents the message list on my, inside my application. So I'm not going to go too deep into some of these ideas, but try to give you just a flavor for how the React stuff is working. So in this case, I've got like a game screen for this quiz, and these JSX components have lifecycle events. And the initial one of when the component is created and first shown is this component will mount. And so when I first show the component, I don't have any list of users. So sorry, my quiz has like a leaderboard, right? I can see who's winning in the quiz. And so when I first start out, I don't have any users, I don't have any state within my front end client. So when the component shows, I'm gonna say, hey, let me get all the users for my game. And I'm gonna call this thing that the Flux architecture calls an action creator. And so this is my list users function. And what it's doing is it's just doing an AJAX call. I'm using fetch, which is kind of like a newer library for making AJAX calls, but you can imagine that this was like jQuery, AJAX, or any sort of AJAX library. So I'm doing a get on my user's endpoint, and then you can see there's this dispatch of the action. I'm making this little action packet, which represents the list of users that came back from the server, and I'm saying, and all I'm doing is saying, here's the list of users, and as an action type, and here's the actual list, and I'm dispatching that into my application. The Redux library, which I used for this project, sort of implements the Facebook Flux architecture in a particular way. It has this notion of reducers. Reducers are functions which take the actions that have been created and apply those actions to the current state of the application. So for users list, it's very easy. I'm just going to return the same list of users. That's my new state, my new list of users in the application. Because it's a leaderboard, I've got this order by point. So I'm actually going to order the list of users by how many points they've accrued in the game so far. For people paying close attention, I'm also showing how we handle the action when there's a new user created. So if anybody out on the internet registers with my server, registers with my game, a new user record is going to get sent over the WebSocket, and I'm going to get this user's create action, which contains just a single user. And what you can see is a little bit of ES6 magic here, where I'm taking my existing list of users as ... state, and then I'm adding the new user onto the end. Now I get a list of, okay, here's the new user set. So now I come back. I've come all the way around my circle now, back to my game tabs, my JSX component. This map state to properties is another kind of Redux thing, where my application state is mapped into properties, which are sort of immutable attributes of a component. You can see that this is the game overview screen, so it's got the list of users for the leaderboard. It's got the state of the game overall, and then this thing guesses, which is the guesses that you've made as a player. And now below that, you can see a little bit of the actual render. So the core function of a React component is to actually render some HTML that'll be built into my page. And so in this case, I'm using some material UI components. I've got some tabs. I'm rendering a leaderboard. And then you can see the leaderboard component over on the other side. So that's the other notion of these React components is they allow you to modularize your application, build reusable components like a leaderboard that you could use in different parts of your application. And it provides a nice model for encapsulating logic, both the state and then the logic for displaying that state together. So you can see in this leaderboard JSX, I'm going to show the user.name and the user.points, and we'll see that later in the game. So this reducer pattern is an interesting sort of idea. So think about my application, people are making changes, data's coming back from the server, and I'm seeing these stream of actions saying there was a new user created, a user got removed, points, somebody earned some points in the game. And so the reducers are a set of functions that I create whose job is to take those actions and apply them to my current application state. And then that new application state gets passed to my components rendered on the screen. They're basically when you look at them, they're a switch statement on this action type, which just falls out of this notion of the command pattern where you create a similar looking packet of information, an action type, and a payload. And what they do is they let you reason about where is state actually changing in my application. And so the real problem that Facebook was trying to solve when they came up with React and Flux was they had this observation that as their front-end applications were getting more complicated, it was just really hard to figure out where bugs were coming from. Data would change, somebody would like something somewhere, and they needed to show that, the new like count in another component somewhere else. And it was really hard to sort of trace the flow of change and data through the application when you have, 300 JavaScript files and anybody could be changing state at any time, and you're trying to set up like action listeners to listen to a bunch of different components. And they found it very hard to reason about as the applications got bigger. So the Flux architecture attempts to kind of smooth all that stuff out and say, we're going to always generate actions whenever we want to change something, and we're going to have this single place to apply those actions to our current state of the application. We're going to have a consistent notion of the state of the application. And so in the Redux library, this is the reducer pattern sort of implements this single place to see things change. So now let's add the real time. So what we've seen the basic make an AJAX call, pull in the initial state of my application, in this case my leaderboard. So this is kind of the sort of key, maybe the key slide for this talk today, which is this insight that if you look at sort of RESTful principles, the idea is we've mapped are standard kind of resource CRUD operations to HTTP verbs. But we can add on to that verb set this notion of publish and subscribe. And so now from the client, in addition to my standard CRUD operations, I can subscribe to changes on a resource, and the server will publish events to me describing changes to that resource. HTTP doesn't really support kind of push very well, so we're going to use the WebSocket because its protocol is designed to allow this two-way asynchronous communication. But the sort of key takeaway here is that if we can take our REST resource list, we can very seamlessly add this publish subscribe notion as just another verb. And we don't need to create new application endpoints to say, subscribe to changes to the leaderboard. I can just say subscribe/users, and that /users is the resource that represents the set of users. And now I can do that for any resource, and I can do it in a very kind of generic way. So let's see a little bit about how this looks inside the code in practice. So we're looking at the server side now, the Node.js side. I've got my socket IO. When I receive a connection, I'm going to set up an event handler for this subscribe action. So when the client says, hey, I want to subscribe to the user's endpoint, I'm going to get this callback. All right. So I'm going to get my subscription. In a real application, you'd have to worry about things like authenticating the user. Do they actually have access to this resource that they're requesting to see a stream of change events about? But for my simple demonstration today, if you go look at the source code, we're not doing any sort of authentication. So the key bit here is this piece in the middle. So I've got these Mongoose ORM models on my back end. Whenever a user is created or modified, I've set up a signal handler in Mongoose that says whenever something changes, I want to invoke this model signals function. I'm going to determine whether it was a new user created or an existing one was updated. I'm going to pass the resource type and then pass the actual document. And then you can see in the model signals function, I'm actually publishing that event now over the WebSocket. The demonstration I'm going to show today is doing this all dispatching locally within a single node process because that's simple. In the real world, you want to run multiple node processes. You're going to have a cluster to handle scale, and so you need to distribute these changes within, across the cluster. For our products at Heroku, mostly we use Redis to do this. It works really well as a pub/sub mechanism, IPC mechanism between processes. All right, so now the front-end architecture, we saw this slide before, and now you can see we've very sort of naturally added in this WebSocket interface. We're going to listen for these WebSocket events, these publish events, and we're going to dispatch new actions into our kind of Flux data flow. So let's see what that looks like. Set up a socket listener, set up a listener for the publish event on that socket, and now call this dispatch from the result of the user API update. So I've created a new action creator called user API update, but it's going to send the same user create action that I saw before, and now my reducer is exactly the code that we saw before. It's just adding this new user into the list. So this is an example of how the kind of very regularized data flow within Flux, the Flux architecture, makes it very easy for us to incorporate a whole new kind of channel of changes in data, in this case, data being pushed from our server backend into our front-end application without any kind of weird contortions or creating new code paths where we have to reason about, this label is showing the wrong number. Where did that number come from? Was that, something happened internally within the app, or did it come over the WebSocket, or, why am I seeing that data? Real-time REST. So this is sort of what we refer to internally as real-time REST. This notion of taking a REST API and layering this publish, subscribe, the subscribe verb on top of it, and being able to publish changes specifically on resources, reusing existing RESTful paths. So this becomes a very nice kind of architecture to be able to reason about or stick with my resource-based sort of access pattern to my back end without having to create any kind of ad hoc API or ad hoc message packet. Today we're talking about WebSockets and sending data out to the browser. WebSockets are very well supported in the browser, but one of the things that I'm interested in is looking at sort of real-time event push being part of APIs in general. There's a number of APIs that have real-time streams of various types across a bunch of different protocols. We don't really have a good kind of industry standard yet for what is the server-to-server protocol for listening for change events. And is that a durable stream? Can I stop listening for a while and then reconnect and replay old changes? Like, we're still kind of working out a lot of these details. But I think I think we're going to start seeing more and more that people have a real-time channel built into their public APIs that that has sort of a standard shape. And right now, the kind of standard for this is webhooks, right? Which is really, call me back sort of functionality rather than, I create a subscription. And maybe that's the right channel. Maybe the right channel is, you make an HTTP request to my server to send me data. We could still have the same basic pattern. I'm going to send a subscription request, subscribe to a particular resource, maybe include in that subscription request the address that I want you to call me back on. But I feel like we haven't quite seen the real kind of interoperable standard for event notification added to a REST API come out yet. Great. Just some quick takeaways. Thick client, REST API, separation of concerns is very cool. Arguably more work than using an MVC framework on the back end, but is a nice pattern longer term. React Flux Redux, JSX, it's a pretty steep learning curve. It's a lot of not moving parts as much as new concepts. I'm not a huge fan of JSX. It's sort of like, it's kind of HTML with code, but it's got like 29 sort of obscure rules to it. Real-time isn't free. If you're pushing out events, all your resources on the back end, we have this for one of our applications. We're sending change events over Redis, but sometimes we need to gather additional data. You're serializing more data with every change, pushing it out over the WebSocket. So it isn't free, but a really good user experience to be able to see stuff updated in real time. I don't know if, I know we use Trello very heavily internally. Trello's one of these apps. It's like everything happens instantaneously. It's very very cool in a collaboration sort of environment. Cool. All right. Well, thank you very much for coming out to everybody. Really appreciate it.